Okay, you guys, so this is video number 2. So we're going to talk about exponents and factoring mostly here. So on number 10 through 13, they want us to simplify these exponential expressions. I've gone ahead and written our main 2 rules at the top here. So remember, when you multiply, you add the exponents, and then power to a power, we multiply the powers. You also need to remember about negative exponents, because as you can see, quite a few of these questions have some negative powers, and we'll also be dividing. So all of these rules, remember, are on your formula chart, so they don't have to be memorized. You just need to make sure you know how to use them, okay? So I'm just going to go over here to number 10. Your first step should always be to get rid of the parentheses. And when I say get rid of the parentheses, I mean because there's a number on the outside of the parentheses. But this 3x squared, right, there's nothing on the outside of the parentheses. So those parentheses are just there to show where that exponential expression starts and stops. So I'm just going to go ahead and drop those parentheses. But then the second parenthesis, we have a 4th power on the outside. And remember, whenever you have a power on the outside, that power has to go to both factors, the 2 and the x that are inside the parentheses. So I have to raise 2 to the 4th power, which is 16. Remember, because that's 2 times 2 times 2 times 2. You can also use your calculator. And then I have to raise that x to the 4th power. So I'm just going to write x to the 4th. So now I don't have any more parentheses, so I'm just going to go ahead and do this multiplication problem. Remember, the big numbers, right, those are just normal everyday numbers, so we're going to multiply them like we always do. So 3 times 16 is 48, right, and then we're going to multiply x squared times x to the 4th. Well, that would be our, when we multiply, we add the exponents rule, right, because we're keeping the same base of x, right? And now we're going to have 6 total x's in our chain of multiplication, right? And so that is going to be our final answer. Okay. On number 11, there's a few different ways you can tackle number 11. I'm going to do it basically the exact same way we just handled that in the number 10. So I noticed that I have a negative 2 power on the outside, and that negative 2 power has to go to both of those factors inside the parentheses. So that's going to give me 4 to the negative 2. And I am just going to keep that as 4 to the negative 2 right now because it's a negative exponent, and I'm going to deal with that in just a second. But remember, my first ultimate goal is to just get rid of the parentheses. Now here we have a power to a power, so that's when we multiply the powers, right? So I've given both factors the negative 2 power, but now I notice I still have unhappy negative exponents, which means they are on the wrong side of the fraction. Currently, right, if I want to, I can make it a fraction and they're both up in that numerator, but they're unhappy in the numerator, right? And so you need to fix that, right? You should never ever leave an answer with a negative exponent. So I'm going to move the 4 squared to the denominator. And I can actually do 4 squared, right? That's going to be 16, but it's going to be in the denominator. And then I'm going to move my x to the negative 12 to the denominator where he's happy, so my exponents become positive. And then, of course, I need a 1 placeholder to hold that numerator open since there was nothing left up there. And that's my final answer, right? You can type in 4 to the negative 2 on your calculator. Just be really careful that you tell your calculator to convert it back into a fraction, right? Because the calculator is going to spit out the decimal point 0.0625. So if you just hit math, enter, it's going to tell you that that's 1/16. So if you want to type that into the calculator initially, you totally can do that. All right, I'm going to hop over here to number 12. There's a lot going on here. I'm going to kind of take this one step at a time. So I'm going to just draw my fraction bar. And I'm going to, hold on, let me get that a little smaller there. I'm going to go ahead and do the division of the numbers because they're positive. They have positive powers, so they're just kind of ready to go. So when I just divide 4 by 2, I get 2. Right, so that's going to go in the numerator. Now what I'm going to do is I'm going to fix all of my negative exponents and get all of my variables where they want to be. Okay, so for example, this u to the negative 4th, he does not like being in the numerator, so I'm going to move him to the denominator where he becomes u to the positive 4. The z cubed appears to be happy where he's at, so I'm going to leave him in the numerator. Then I'm going to go to the denominator, my u, oops, sorry about that. My u to the 6th, he looks perfectly happy with that positive power. So I'm going to put him in the denominator. I'm just going to leave him there. And then my z to the -2, not happy in the bottom, so he's going to come up top. I didn't need quite so long of a fraction bar, so I'm going to kind of fix that. Right, and so that's what we get so far, right? We've made all of our exponents happy, but then of course we're not quite done because we still want to combine, right, these like bases, right? We've got 2 z's on top and 2 u's on the bottom that we need to merge together. So we're going to use that product property, right? That when we multiply, we add the exponents. So our final answer is going to end up being 2z to the 5th, because 3 z's and 2 more z's makes 5 total, right? And then I would have u to the 10th power in the denominator. And that's going to be our final answer. All right, our last one over here. So very similar to the one that we just did in terms of kind of what that looks like. So again, notice that we have the 6/9. Now that's a little bit different than the previous problem, right? Because the previous problem was 4 divided by 2, which is a nice pretty whole number. 6/9, 6 is not divisible by 9 as an integer. So, but we can just reduce that fraction. So I'm just going to reduce the 6/9 to 2/3. And again, if you want to, you can type that in your calculator, 6 divided by 9, and then hit math, enter, or use your fraction mode, and it's going to tell you that that's 2/3. And then I'm going to do the exact same thing I just did a few minutes ago. I'm going to write all of my variables. I'm going to move the ones that are unhappy. So that x squared, he's great where he is. The y to the -5th, he doesn't like it there, so I'm going to move him to the denominator. Then I'm going to go to my denominator, that x to the -6, not happy there, so I'm going to bring him to the top. But then my y to the 7th is perfectly happy in the denominator, right? And so we're close to being done, right? We just need to finish it off by, again, merging those like bases together like we were just talking about earlier, right? So we need to get all the x's together and all the y's together. So I'm going to end up getting 2x to the 8th and then 3y to the 12th. And that's going to be our final answer. It's all reduced. All of our like bases have been merged together, and voila. All right, our next section is factoring polynomials. I've put a little reminder over here that it depends on whether your expression is a binomial versus a trinomial. So if it's a binomial, you have 2 options, right? It's either a GCF, where you can factor out the greatest common factor, or it's a difference of 2 squares. Please remember, a difference of 2 squares looks like this, right? Difference means subtraction, and then the first term and the last term are perfect squares, right? Typically, it's going to look something like this, like x squared minus 9, right? X squared is a perfect square, 9's a perfect square, they're being subtracted, so that's a difference of 2 squares, right? So, and there's a formula for that to make it easy, light work for you. And again, that formula is also on your formula chart. All right, and then if it's a trinomial, that's when you're going to want to do your number puzzle, right? Remember the x. And then you want to rewrite it as 4 terms and then factor by grouping. Okay, so we're just going to practice that here for these few problems. All right, so here we go. This is a trinomial. There's not a GCF, so I'm not going to worry about that. You should look for GCFs, of course, always. So I'm going to make my little x for my number puzzle. So remember, what we do is we multiply our a times our c, right? So we're going to multiply 7 times 32, which is 224. So we want the only 2 numbers in the entire world that multiply to give us 224, but add to give us that positive 60b term in the middle. Now, those are some pretty big numbers, so if you don't know what those numbers are, remember we learned a little trick in our calculator to help you find those factors. Let me scooch that over. I'm just going to write this down one time. So you're going to go into your y equals button, and in your y1, you're going to type in 224 divided by x, so your calculator will find all those factors. And then in y2, you're going to write 224 divided by x plus x, because we're looking for the ones that add to give us 60. So I'm going to do that really quick. And the whole goal here is, of course, I'm looking for and then go look at the table. I'll put look at table. There we go. The little eyes. There we go. All right, so I'm gonna go look at my table, and you're gonna have, my table's way out of whack, hold on. You're going to have 3 columns. You're gonna have your X, your Y1, and your Y2. You're gonna be looking in that Y2 red column on the far right, and you're looking for the number 60 in that far right red column. And I see mine right away, right? Because my table is starting at 0. So as soon as I went and looked at my table, let me change colors here real quick. My calculator is telling me that it's +4 and +56, right? That these are the 2 numbers that multiply to give us 224, but add to give us 60. And I can tell that that's correct. All right, you don't have to use the calculator if you don't want to, right? A lot of times we can just figure out what those are in our head, or we can write down a list of factors. All right, so here's what we're gonna do. I'm going to take that 4 and 56, and I am going to rewrite my +60 as +4x plus 56x. So I'm going to use those 2 numbers that I just found, and I'm going to split that 60 back up. And then I'm going to bring down my 7x squared and +32 from the problem up top. So I took my 3 term, I did my number puzzle, and then I wrote it as a 4 term. And now we do the 3rd step, which is to split it down the middle and factor by grouping, which is essentially just taking the GCF 3 times in a row. Hopefully this is all coming back to us. All right, so the only thing that 7x squared and 4x have in common is an x. So if I take out an x from each one of those terms, or divide out an x, right? Remember, we're dividing an x when we take out that GCF. And over here, it looks like 56x and 32. It looks like the only thing they have in common as a GCF is +8. And if I divide an 8 out of 56 and 32, I'm going to get 7x plus 4, which makes me very happy. Remember our little smiley face, right? We're very happy because our parentheses are identical, and that has to happen if you have factored correctly, right? And then we do GCF one more time. These 2 terms have 7x plus 4 in common, and then the x plus 8 is the leftovers when we divide that out. And there's our completely factored polynomial. All right, so I took a really long time to explain that one, so I'm going to go a little faster as we go through these last few. All right, when I go to number 15, I notice on number 15 that is clearly a binomial. So remember, with our little notes over here, the only way we can factor binomial is either a GCF or it's a difference of 2 squares. This is clearly not a difference of 2 squares because 3x is not a perfect square, which means it's a GCF problem. And it looks like the only thing those 2 terms have in common is an x. So I'm going to factor out the x, which leaves me with x minus 3, and that's it. Those are our 2 factors. Ta-da! All right, moving along here, number 16. So number 16, you could work this problem right away, just like we did the one above on number 14. However, what catches my eye is that every single one of these terms is divisible by 5. So I'm going to take out that GCF of 5 at the beginning. You either have to do it at the beginning or the end, so that's up to you, but you have to do it somewhere. I would prefer to take it out at the beginning because that makes my trinomial numbers much smaller and easier to deal with if I take that 5 out. Don't forget about the 5 though. He's one of our factors, so we want to make sure we don't forget about him. So now I'm focusing all of my attention just on this trinomial, right? So then I'm going to go off to the side. I'm going to do my number puzzle. I'm looking for the factors of 20 because there's an understood 1 right there now. So 1 times 20 is 20. So I'm looking for the 2 numbers that multiply to give me 20 and add to give me 9, which are clearly are going to be 4 and 5. So I'm going to rewrite my trinomial as x squared plus 4x plus 5x plus 20, right? I took that 9x and I split it up. And then we need to factor by grouping, right? So we're going to split it down the middle, and then GCF, GCF, GCF. So I'm taking out the x. Then I'm taking out the 5. Got my little happy face going because my parentheses are the same, which is exactly what I need to see. If it's not there, then I shouldn't be moving on. So I'm taking out the x plus 4 they have in common, and then the x plus 5. And then, of course, I don't want to forget about that 5 GCF that I took out at the beginning. If you don't take the 5 out at the beginning, then one of your factors is going to be, it's going to have a GCF of 5 in it, and you would need to see that at the end, okay? All right, number 17, this is a binomial. So again, if we look back up here, right, it's either a GCF or it's a difference of two squares. Well, there's nothing in common. 4 and 25 have absolutely nothing in common factor-wise. So this is a difference of two squares. And I know it's a difference of two squares because remember, a perfect square means I can multiply something by itself to get that. And 2x times 2x is 4x squared. And then, of course, 5 times 5 is 25. So this is how I know it's a difference of two squares. Plus, it's a subtraction problem, which is what difference means. All right, so this is definitely a difference of two squares, and that makes it very easy to factor because that means the front of my factors has to be 2x, the back has to be 5, and then our signs have to be opposites in order to get the difference or the minus sign in between. And there you have it. All right, number 18, I don't see a GCF. Right, they don't all have something in common, so I'm just going to hop right to my number puzzle. All right, and so I'm looking for, if I multiply my A times C, that's going to give me positive 100. So I'm looking for two numbers that multiply to give me positive 100, but add to give me negative 20. Well, that is going to be negative 10 and negative 10. And again, you can do your calculator, use your calculator for that. So this is going to give us 4x squared minus 10x minus 10x plus 25. So I'm splitting up that middle term. And then I'm going to split it and factor by grouping. I feel like a broken record. Right, I just keep saying the same thing over and over. All right, so let's see this side. It looks like they have a 2x in common, which leaves us with 2x minus 5. And then over here, they have a negative 5 in common. Please don't forget that if the right side starts with a negative, you have to take out a negative. You don't get to choose. So if I take out a negative 5, that leaves me with, what do you know? 2x minus 5, smiley face, identical parentheses. So I'm going to take out that identical parenthesis of 2x minus 5, and my leftovers are 2x minus 5. So those are my two factors, and you can either leave it like that, or since our factors appear to be identical, we could write our answer as 2x minus 5 squared. Voila. All right, our last factoring question. So 5x squared minus 125. Again, it's a binomial. It is not a difference of two squares right now because 5 and 125 are not perfect squares, but I do notice that they do have a 5 in common. So I'm going to take out the 5 minus, what's that going to give us, 25. And then some people may stop here, but you don't want to stop there, right? Because we need to recognize that the factor that was remaining is a difference of two squares, right? And so we need to notice that, oh, I'm not quite finished. I took out a GCF, but x squared is a perfect square, and 25 is a perfect square, and it is a difference problem. So I'm not done completely factoring. I have factored it once by taking out the GCF, but I need to keep factoring until I can't factor anymore. So the x's have to go in the front, the 5's in the back, and then plus minus. And then, of course, I don't want to forget the 5 GCF that I took out at the beginning. All right, so this is a GCF and a difference of two squares. Okay. All right, moving on to number 20 and 21, which is division of polynomials. So we talked about this. Notice that both of these problems are written horizontally. I don't like writing my division problems horizontally. I would much rather write them as fractions and write them vertically. So I'm going to go ahead and do that. And I'm dividing by m plus 4. Please remember you are not allowed to cancel or reduce fractions when you have terms, and terms are separated by plus and minus signs, right? You're not allowed to do that. So you're only allowed to cancel out factors. So what we need to do is we need to recognize that our numerator is a trinomial that is factorable. So I'm going to come over here off to the side, and I'm going to do exactly what we've been doing for the last 10 minutes in this video, right? And I'm going to factor m squared plus 9m plus 20, right? By finding the two numbers that multiply to give me 20 and add to give me 9. This looks familiar. We had these same numbers just a few minutes ago. All right, so this is going to be m squared plus 4m plus 5m plus 20 when we turn it back into its 4 term. And then I'm going to split it down the middle. And I'm going to get m plus 4, and then take out a 5, which also gives me m plus 4. So my factors are m plus 4, m plus 5. Well, that's super handy because now I can rewrite my numerator as m plus 4, m plus 5 instead of a trinomial. So now it's factors, and then of course our denominator is m plus 4. And he can be in parentheses if he wants to, but you don't have to put him in parentheses. I'm just going to, so you recognize that this entire factor and this entire factor, right, we're dividing, so they actually cancel out to give us 1. So our answer is just m plus 5. All right, and because that's what's left over when we divide out the m plus 4 factor. Okay. All right, and then we do the exact same thing on number 21. All right, so here we go. I'm going to rewrite mine as a vertical division problem. So I'm dividing by x minus 6. Again, do not reduce. You cannot do that, right? You cannot reduce terms. You can only cancel factors, right? So we need to factor this top polynomial, right? But he is a binomial, and he is a difference of 2 squares. So he's a pretty easy one to factor. I know x squared breaks up into x, and 36 breaks up into 6 and 6, and my signs have to be opposites. And then, of course, notice that little x minus 6 there in the denominator. And so those are going to cancel. And so my final answer is just the x plus 6 factor that remains. Okay. All right, last few here really quick. Number 22, what is the volume of a rectangular prism that has the height, this length, and this width? Well, you just need to remember, we've seen this on tests before, right? That volume is just length times width times height, right? So when they're asking you for the volume, they literally just want you to multiply all 3 of those expressions. So 6, I'm not even going to put them in parentheses. I'm just going to put them in little multiplication dots. So 6x squared y times 2x squared y cubed times 4x to the 5th y to the 9th. And you're just going to this is just exponent rules, right? Pretty basic ones at that, right? So remember, numbers just get multiplied together as they do, right? So we're going to get 6 times 2 is 12. 12 times 4 is 48. Then we want to get all of our x's together. So we've got x squared, x to the 5th. So remember, when we multiply, we add the exponents. So it looks like that's going to give us a total of 9 x's. Right, and then we have 1y, don't forget his little power is 1, and then 3 more y's and 9 y's, right? So that's what, 13 y's? And that is our volume expression, right? Just multiplying the length, width, and height. All right, lastly is just practicing simplifying radicals. So this is our factor trees, right? So I'm just going to breeze through these pretty quick. So 108. Some of you guys are probably getting pretty good at these where you can do them in your head. If you can, that's great, right? Remember, we're looking for pairs of numbers, right? You got to have a buddy to leave the house, as our expression goes. So I'm just going to I'm going to start with 9, because I know 9 goes into 108 12 times. Or you can start with 2 and 54 or 3 and 36. It doesn't matter what you pick to start off with, as long as you keep breaking down those tree branches until you get down to your prime numbers. So 9 breaks down into 3 times 3. So I'm going to circle those. 12 is definitely not prime because I can break that down into 2 times 6 or 3 times 4 or whatever numbers you want to pick. It does not matter. We'll all end up with the same answer at the end. And then, of course, 6 splits up into 2 times 3. So no matter how you break yours down, everyone should be getting 2 times 2 times 3 times 3 times 3. And then what we're looking for is pairs of numbers. So I have a pair of 3s. I have a pair of 2s. That means I get to take out a 3 and a 2. You don't have to show all these steps. I'm just doing this. I'm taking out a 3 to represent that pair, a 2 to represent that pair, and then this sad little 3 over here, he did not have a buddy, so he has to stay inside. And whenever you take multiple numbers out or keep multiple numbers in, they just get multiplied back together. So our final answer would be 6 root 3. Okay. All right, so I'm just going to fly through these other ones here pretty quick. Let's see. I'm going to do 200 down here. So I'm going to get kind of crowded. So 2 times 100, 2 times 50, or you can just do 10 times 10. You found your pair, and that's totally fine. And then 5 and 5. So I've got 3 2s and 2 5s when I break it down to my prime factors, which means I have a pair of 2s and a pair of 5s. So very similar to the last problem, I get to take out 2 numbers, right? So I get to take out a 2 and a 5, which is going to give me 10. And then my lonely little 2 that didn't buddy up, he has to stay inside the radical. All right, number 25. Notice on number 25, you already have a 3 multiplier on the outside. Don't forget about him, right? So when I do my 45, I'm just going to do 5 times 9, which is 3 times 3. So that's a pretty short little tree to get to my prime numbers. And you'll notice we do have a pair that we get to take out, right? We've got a pair of 3s, but there's already a 3 out there, right? So I have 3 times, and then I'm taking out a 3, right? And so that's going to end up giving me 9 root 5 because I already had a 3 multiplier on the outside to multiply by the 3 that I was taking out of the radical. Okay, same thing's happening on number 26. We have a 2 multiplier hanging out there already. So whatever gets to come out of the 98 is going to get multiplied by that 2. So 98 is 2 times 49. And 49 is 7 times 7. So again, a nice short little factor tree, nothing too crazy. And I noticed that I do have a pair of 7s. So I do get to take a 7. So remember, there's already a 2. I'm taking the 7 out though because of the pair with the factor tree. And then of course this little 2 that didn't buddy up. So my final answer would be 14 root 2. All right, and we need this skill, right? Because on our next video, we're going to be practicing solving those quadratic equations, and simplifying radicals is a big part of that. All right, I'll see you guys in video number 3.